Hello everyone. So in this video we are going to solve this problem from HMMT, that is Harvard MIT Math Tournament. So this is the question from geometry paper, and I will give you the link in the description so that you can download and solve the remaining problems if you want. So this question is very basic. Any 10th class student can also solve it, and if you solve it correctly, you'll get the answer 191. So if you want to give a try, you can give a try to it. So the question is, let HORAC, horse, be a convex pentagon such that angle EHO, angle ORS, angle SEH is 90 degree and angle HOR, angle RAC are 135 degrees. Given that HO is equal to 20, S is equal to 26 and OS is 10, compute the area of horse, the HORAC pentagon. Now this is actually a very basic question. But sometimes the question what looks basic has some hidden thing. So we can solve this question by geometry as well as trigonometry. So I again request please try it. So the question is simple. First of all, try to draw the diagram correctly. So the question is that there are vertices HORAC, but drawing diagram is itself a challenge. You have to just tweak 2 or 3 times, then only you can draw the diagram properly and understand the question. So the HORAC be a convex pentagon, EHO. So now notice this statement, HOR and RAC are 135 degrees. These two consecutive angles, HOR and RAC, are 135. So how we draw it? Let's say I have H here. This is the vertex H. I draw a line, and from here I'm trying to make 135 degree in this way. So this angle will be 135 degrees. From there, again you notice that RAC, this is, let's say, R, and SE. So RAC is 135 degree. But you notice one thing here, that ORS is 90 degree. So ORS 90 degree means we are taking a 90 degree, is perpendicular to this, like this one, and this angle is going to be 90. So let me just shade this as 90, and after this again you notice that they are saying RSE, so this is going to be S. And here how do we write the S? So let me just take this a little bit smaller, and this, let's say, S. And why it is actually I'm taking a smaller, because you see one thing here, the length HO is 20 but the length SE is 26. So this is 20 here, and SE I take 26, so it'll be greater than this OH, and this is SE. So now where do you stop E here? Because SEH is again 90 degree we have. So SEH 90 degree means this is again E I have, and this is horizontal line. So in this way we are successfully drawn this 90 degrees, because EOH is 90. So this is 90 here, again this is 90 here, and this was already 90 we have drawn. We have to find out and by the way this angle is also 135 degrees. So this is again 135. So let me write it here. 135 degrees. Now we have to find the area of this pentagon, not triangle. So how do we find it? So now it's not difficult because this is 26 we already have. So what we are going to do is we are drawing a line horizontal or parallel to HE, like from O we are drawing a line perpendicular to this ES. This is again 90 degrees. Let's call this point as M. If this point is M, we can now notice that we have area of horse. Let me write here, area of horse is nothing but the area of home, HOME, plus area of ORSM. ORSM. But notice the area of home is already we know. How we know that? Because this total was, this 26 is not the 26 length of EM. It was completely till ES, means SE is 26. So this must be again 20. So this we can find by just finding out the length HE. And how do we find the length HE? Since notice that the OS is given. So if we join O and S, we again find a new triangle here. And now I can just split in this to two. This thing I can write the area of OSM and the area of the OSR. All right. So is it helpful to find out the length OM or the length HE? You notice that this length is already we have, that is going to be how much? HO is 20, SE, so this is OS is 10. How this will help to find out this length? You notice that the MS I have already 6. MS length is 6 and OS length is already given 10. And in triangle, which triangle? I can write with triangle OMS. I can use the Pythagoras because 10 and 6 is known, so I can find the OM length as 8 because 10 square minus 6 square. So this length is 8, so this is 8 here. So the area of home, I will get it what? 20 into 8. Now I have to find out two other different areas, the OSM and the ORS. So these two triangles I have to find. So let's first find OSM. What is OSM? OSM. This is also a right angle triangle. Even the ORS is also a right angle triangle. If you are able to find the side lengths of these triangles, then it will be easy to find the area. How do you find the side lengths? So first we find the area of OSM. That is not difficult. So let me just show you. This is OSM I have. And in this already I found this 8. So area of OSM is simple. This is half into base into height. So base is already I have, this is 6 and this is 8. So that is going to be 24. Now our last task is to find out the area of OSR. So for area of OSR, I'm going to take the RS length. Let the RS length is A and the OR length is B. Now this 135 degrees, the given information we have not used so far, and that is going to be used here. And how do we use it? You see, you notice, suppose I'm taking, let me just take a little, this thing a little bit, okay. So I have actually enlarged this picture just to make this clear understanding. So what I have zoomed there, suppose I'm taking this as alpha, this is theta. So you notice that the total angle HOR was 135 degrees. So I can write this entire thing in this way, that the alpha plus theta plus 90 degree is equal to 135 degrees. Because you notice that this angle was 90 and this is theta and alpha we have assumed. So in this way what I got is alpha plus theta is equal to 45 degrees. Now from here what we can think, that in triangle OMS or OMS. So in triangle OMS I can write tan theta is equal to, notice the tan theta, this is base, this is perpendicular, and this length already we know 6, this is 8. So I can write tan theta is 6 by 8, that is going to be 3 by 4. Now if I know the tan theta, I can also find tan alpha. How do you find it? We know tan alpha, I can write tan of 45 degrees minus theta. So that is going to be 1 minus tan theta by 1 plus tan theta. And when I substitute this tan theta with its value, that is this one, so what we are getting is 1 by 7. So 1 by 7 in this triangle, we've already assumed that in this triangle, you notice that RS I have taken as A and OR I have taken as B. So let me just mark it here, B and A. So I can write tan theta is equal to B by A. It means I got here B by A is equal to 1 by 7. And from there, I'm getting that 7B is equal to A. And also notice in this particular triangle, A square plus B square is equal to 10 square because the hypotenuse is known. So I can use these two equations. The second one was A square plus B square is equal to 10 square. The first one was 7B is equal to A. Substitute this A value there is going to be 7B square, that is like this, and B square is equal to 100. So I get here 50 B squared is equal to 100, and so I get B is equal to root 2. Once I get B is equal to root 2, I get the A is equal to 7 root 2. And again, this triangle was the right angle triangle. So the area of this ORS, which was not calculated so far, so half into A into B. So A was 7 root 2 and B was root 2. So we substitute this value there. And luckily we got again an integer value there. And what is this thing? That is going to be 7. So we have to add all these three areas of these three triangles. So this is 160 here, and 24 plus 7 is 31. So 160 plus 31 is 191 as the correct answer. I hope this question is not so difficult. Any class 11 student can do it. And I hope many of them who have watched this video have done this question by themselves only. So in the subsequent videos of PYMT, the problem you must try series, I'm trying to bring some good questions from different competitive examinations across the world, also from some classic books. So that's all for today. See you in the next video. Stay math active.